looks like I'm almost live. There we go. And I'm live. Yeehaw. Here we go. I do apologize. The stream has started a little bit late. I just had to get some stuff going and working here before. This live stream is going to be showing how to import and otherwise be able to create an assembly program which you can then use in game and create your own code. So I just created this user this evening, just quickly here, called live test user. And as you can see, this is how you normally sign to the game. So this is the normal workflow here. You telnet to the game server, or just go to the web interface, either or, and then it basically gives you blah, 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 etc., etc. Once it's connected, you log in. It gives you all this information. It gives you message of the day information, and then of course down here we have the last login, never, and then the IC starts up, and this is open that reset, blah, blah, etc., etc. So now that we have our system here, now most people don't know exactly how to get started and things like that. So first commands you should know is help. Help basically gives you a nice little help command. If you go plus help, you'll have access to that. You go at help, and you have access to that, right? So, and it is you can do tab completion as well. So I do connect. I can connect to the host that I've just assigned. So let's connect to it right now, and we'll get on with the example here. So we'll connect to it. Right here, it provisioned the system. It's my first time connecting to this host because this is a brand new character. It provisions it. You won't normally see this. This is a testing environment, and then we have the ASM, and this creates the image. It's letting us image from test. Selects from ROM BIOS, checking segments used, blah, 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 and then attempt to boot OS, and then you can boot. Ta-da! Here we are. So now we have a beautiful OS image here, as you can see. And now the next thing what we're going to do here is I'm actually going to show you how to easily import code I want to show you how to create a quick assembly program and then how to import that into the game. So I'm going to move this window out of the way for the moment. And the first things you're going to need is you're going to need programs called CA65 and then LD65. And then, of course, a way to actually build the file. So I'll actually build it manually for this time being, just to show you how to compile an assembly program without using a make file, and you can just put that into either a batch file or a local shell script, etc., to actually compile your custom code you want to create. So this is a file you're going to want from the dev kit here. This is the IO API include. This includes a bunch of very useful address locations. As you can see, lots of useful locations here. So, another tool that's going to be very helpful too is inside the VM itself. One of the more useful tools you're going to be using, most likely, is HEMON. I will explain HEMON, and then soon I'm going to be releasing this tool in the next version of HackerOS, which will allow you to run code from anywhere in memory, which is going to be useful in a few seconds when I show you what I'm going to do. Okay. And the next thing we'd look at here is very important, is also the kernel inc file. This file has various helpful utilities in that for printing null terminated strings, etc. A bunch of other utilities there as well. And now the config files are also equally important. This is the config file that's distributed with the dev kit here. We're actually going to modify this file just as an example, because I'm not going to import. I want to import the file first using a hex format, just to make things simple if you don't have to worry about FTP in that, because not every user is going to want to use FTP. So what we're going to do is we're going to make the code live at 1A. You can't be at 800 for this, because brun and HEMON start at 800 as well. So you have to change this to something else if you want to be able to do code importing. So we're going to do at 1A as an example. So we're going to save this config file. So now we have hebin config with a code segment address of 1A00. Okay. Now I need to basically create my code here. So right now, so we don't have the file here. So I'm going to quickly. So what I'm going to do is I'm going to do something very basic. I'm going to do a touch live test.s. S is the standard file format for assembly code. So now we have the live test s. We refresh our thing here. Go to ASM, go to here, and I should have a live test right. There it is, right here. Okay. So now here is the basics of writing a assembly-based program here. So since our program is going to be using 65 CO2 opcodes, we have to make sure this is also targeted towards the CC65, CA65 assembler. There's other assemblers out there such as the Acme and a few other ones, but I'm not going to get into those. I'm just going to work with the CA65 assembler. So we go .set CPU 65CO2 to set our CPU. We can use the additional opcodes. We want to go import. We want to actually for this code we don't actually have to import IO base, but if you want to use certain IO locations, you might want to import that, but you don't need to. We want to do this though. We have to export our main function because since this is being targeted towards our Hacker OS, this has to be set in order for actually this doesn't for our custom code though. Because if we're going to do importing, we don't need to export main. That's very true. Yes, I'm not going to be actually compile. Yes, so yeah, since we're going to do the import method first, I'm not going to use the main function. We're not going to export. Actually, no, I can still export main. That's fine. I can still export main. This doesn't matter. So then we're also going to include. We're also going to include our IOAPI.inc I showed and mentioned earlier, and include kernel.inc. Very needed functions there. And then this is our first segment, read-only data. We're going to have a message, which is going to be our intro message. It's going to be a set of bytes. This is an example 65CO2 program. That A means a enter. Then we're going to continue our message on the next line. What is your name? And null terminate the string. There's our string, null terminated. Next, we're going to go my name. You can feel free to put your name in here or anything else, but I'm going to put Chronoboy as that's my Hacker's Edge handle. And then we're going to go to. I couldn't think of a variable name for this. We're just going to go wow message. It's perfectly fine. As you can see, for assembly, these are just these are kind of everything's a pointer essentially. So, not everything I guess, but as you can, everything's an address location in memory. So like labels and code labels and variable labels are interchangeable. So you could accidentally jump to code up here. So make sure you can find your own distinct way to differentiate strings from integers from anything else, because it's you have to be quite careful when handling your variables. Well, that's my name too. I know, very corny, but whatever. It's an example application. So, and this is the basic of the basic. There's going to be nothing complex in this assembly program. This is actually the most basic assembly code you can do right now. Well, the most basic. I can go hello world, but I wanted to go something more nice than that. Then, oops, not great. Greet. Then nice to meet you. And this is going to play into our name in a bit. So now BSS is uninitialized memory. This is stuff that's not stored in our binary itself. These are just like variables that are uninitialized. So we're going to use a name variable, and we're going to reserve 40 bytes and ensure they're initially zeroed out. Then .code. Here's our code segment finally. So name OK. LDA. Wow message. Oops. LDX. All kernel. Most of the easier kernel calls use LDA and LDX for low and high bytes. So low bytes in A, high bytes in X. Same thing as Intel, I guess, where you have AX. This is just A and X together for your low byte, high byte. And then we JSR to our kernel print function, which is fetched from our include file. And then we break because that's all we need there. and then we go main. Here's our main function, and we just do LDA, message. Actually, I don't want to tap that. LDX message. This is again another kernel call. This is pretty repetitive. It's like the put statement in C or your standard print statement. As you can see, assembly is pretty long-winded. And now we're going to get to our input statement here. So LDA. This is our location for where we're going to place our name. And JSR input. Or actually, first, we should know what I should do. I want to push A because we need this after. So we're going to push A and push X. PHX is actually 65CO2, not 65O2. That's a new opcode, which makes things easier. Or else before, without that, you'd actually have to transfer X to A and then finally push A again. So this 65CO2 does make things a bit more easier. So we do that, and then we're going to do, now we have to store. This is for kernel call. So we store STA and STX into param1 and param1.+1, and then we're going to go LDA. We're going to load our name, the name we want to check for. LDX, STA, param2, STX, param2+1. And then we finally go JSR CMP string. We do our compare string routine, and then we load our result. These are all from the kernel inc. And then if it's branch of equal, we go to name OK. So we go up all the way up there to name OK if the branch is fine. If the name is equal, then we do LDA greet LDX greet JSR print. We jump to the kernel print function. Then we pull X. We pull A. As it has to be the reverse of this, of course. If it's not the reverse, then you're not going to. It just pushes into the stack. So you have the way you push, you have to pull back in the same direction, the same ones. If you don't, you'll run into problems. And then we do a JSR to print our name. This saves lots of bytes. Rather than reloading our name variable again here, we just save bytes by doing this. This is only 2 bytes long rather than this, which is actually 6 bytes long. Yes, 6 bytes long. So it's much more efficient code, and it also runs faster too, doing a pull from the stack. And then we do LDA, we load our enter, and we store that to cout. Also, that's in IO API, and then finally we do our break. Now this code will compile fine with the HE bin header I'll show you how to compile that after. But for now, since main is right here and code starts right here, this is actually going to end. This is actually going to run into a problem, as you'll eventually see. So if you go to the config file, we go into HE bin config. We want to save that. So what I'm going to do actually is I want to make a startup. Or actually, I actually can't use HE bin config. No, I can't. So I want to put this back to 800 actually. And then I'm going to go hebrun.config because we actually have to have a separate one here. So refresh this again. Go into ASM hacker. So, but we can actually the best one to copy will probably be HEROM. This is the more basic one. If you want to start from a more easier base, this is probably the best place to start. So we'll copy this one. Actually, maybe not. No, actually I'll just copy HE bin. This one should be fine. And then brun. So okay, and then I want to load it into 1A in memory. That's where our start address is going to be. then what we don't want is brun doesn't have a header, it doesn't have startup, it doesn't have once. It just has code, read-only, data, and BSS. And we don't have to worry about anything else. That's perfect. That's all I need to worry about here. Okay, and then we can save this, and then we got to go back to our live test again. And at the very top here, since everything starts at code, and so our code starts here, we'd actually want to do a jump to main. If we don't do that, then it's going to start running this first, right? So we got to make sure we don't run that first. And let's go back to brun for 1 second just to make sure that works. Okay, it looks fine. Okay, now I will show you how to compile the code. So now we just do CA65 live test S. There we go. Now I should have a live test.o file. Now we can go ld65-c config brun config, and then we do a .o live test.bin, and then finally we want to link it with live test.o. We don't link it with any other files because we're not linking towards the OS at all. We're just making a raw binary image here. So now I should have live test.bin now. So now here's the total file size of our binary file. So it's only 172 bytes, pretty damn small. Okay, now I do believe I have a Python file here. Yeah, I have a file called 2hex here that I wrote a while back. This file here just does a nice little conversion. It imports a file called intelhex and does a bunch of other interesting stuff. So what I need to do here, just give me a moment. Okay, and then we need to, that should be fine actually, it's perfect. So the offset is argument 1 and then the file is argument 2. So let's bring this back here and show you how this works. So Python 2hex, and then I said the first one is the location. So oh yeah, so it's int of that. So we're going to go 1A00, and then it's going to be live test bin, and hit enter. Now I can cat output hex, and this is now our hex code we can import directly into the game engine. So now I'll show you how to do this. So here's our game code here, right? So now is the fresh image as well. So there's nothing in memory. Actually, to show you, I'll bring up the memory browser for a second here. Just give me a moment. So what image is this? This is 96.219.144.29, right? So hosts 996.219.144.29, right? Memory. Okay, so here's the current host memory. So if we go to code segment, should be, that's the ls, or, oh no, that's the bootloader. Yeah, the bootloader was there. Yeah, because this is a fresh boot. Or no, that's the list. That's the ls command actually right there. It's ls. Okay, so if we go to 1a, right down here, I should find 1a. Here's where we're going to load the code. We're going to load the code right here, our binary code. So what I'm going to do is I'm going to close this back up for a moment, and we're going to load it in. So to import code into your host, just you have to halt your host. So press hold Control and press D. This will bring you back to your in-game system. So then you import, and then press Tab again, and it'll automatically fill your host information there. Then hit Enter. Then it'll ask you to paste in your hex code. Then just take the hex code you exported as such, like that, and then just paste it in and hit Enter. And then now it's imported. Now, if I go back to, just want to show you that it is imported. You never get to check this. I've been using this hex importing for like a long time before. And now if we go up to 1 to 1A, and I want to show you how to run the code in two different ways as well. So here's the code here we imported, see? So your code, all your code segments is here. And then down below is as you can tell, it's the read-only data that we added to our code. So there we go. Now, if we go into, where is it? Here it is. So we'll press up a couple times, press enter to reconnect to the VM. Now, first I'll show you the new brun command that I'm working on. So 1A00 I imported into, right? I hit enter. Boom. Oh, that should have worked. I haven't tested brun yet, so. Okay. It's obviously not working right now. Anyways, that doesn't matter. So we can go hemon anyway. So we're going to run hemon. And then to run the code through hemon, which is available right now, go 1A00 and then space R. Enter. There we go. Here's the code we just imported. Essentially, brun did cbrun partly work, but it didn't work all the way. It didn't actually run the code. I don't know why. I have to look into that. But here we are. This is your examples of what you work on. So let's go Bob. Nice to meet you, Bob. Right? It brings you back here because the BRK. So run hemon again, and then do 1A00. Enter. Oh, R. What's your name? Anyway, ta-da! See, and that's how you import a basic hex file into your game. Once I get brun working, that'll be released in the next version of HackerOS, and you'll be able to use that to perform your import as well. So now, the next thing you guys are probably wanting to know is how to do the FTP component. Let's look at that right now. So we're going to close this. We're going to go out of the host. We're going to go to our live test. And what we're going to do is we have to export main, but this time we're going to remove this code here. We don't need this anymore. We save that. And now we can go back to our compiler here. And then we're going to go LD65. Actually, I got to make hebin hebin.o. There we go. Yeah, hebin.o is included in the distribution, so you don't have to worry about that. This is just I just ran a make clean a while back. So, and then do this, and we go config hebin.config. And then we do a .o for our output file. We want is going to be live test.bin, and then we just do live test.o, and then hebin.o, and then we hit enter. There we go. And then the size of this file is a little bit bigger because it has a header. So this time it's 183. And now live test.bin is the file we essentially want to import into our FTP. So we're going to open the file manager here. Okay. So now here we should be able to look here and see live bin, live test.bin. Here it is right here. Okay, so I'm going to go as well here. We're going to do a quick ls. I want to remove brun.bin, remove a few other programs, because there is a file limit. There is a file size limit. How many files you can actually have on your host. Let's delete a couple files there. Okay. And next, I just need to start the FTP server. Okay, FTP server is started. Now I need to open up a new window here because we need to be able to copy it over. So here's how to connect here to FTP. So ftp://ftp.hackersedge.com:2021 and hit enter. And then here you enter in your character's name, live test in this case, and then our password. And then hit OK. And here we are. And guess what? There's our host. Click onto it, and look what we have here. We have our little host files, right? So now let's take the file and put it in. So where's live test? Live test bin. So we grab this and we copy it in. Boom. Look at that. There it is. Now let's go back to our host. Do an ls. Wow. Isn't that awesome? And now type in live test. Enter. Huzzah. Brilliant. And that's how you can upload files into Hacker's Edge. Right now the FTP server is alive and active for every character. Just connect to ftp.hackersedge.com, enter in your character's username as the username, and in your character's password, and you'll be able to upload binary files into the host. And if you use the developer kit, you'll be able to compile programs that actually run. And yeah, there you go. And that's almost the end of this video, I guess now. That's all I really wanted to show, is how to basically create a simple program in assembly and place it in. I guess maybe I'll just quickly go through a couple small little things here before I end off. So if you're going to be creating tools, you're going to want to actually know a bit more about the kernel. Also, you can compile C programs the same way and just upload the bin file that way as well too. It works with C files, assembly files, doesn't matter. And actually the make tool is actually very helpful. I'll show you on the website where you can grab everything. Just give me 1 second here. I just got to where is that? Okay, just give me one moment here. I just gotta do one small thing here. So here's how you can access the dev kit. So if you go to www.hackersedge.com, go to dev kit, and then from here you can go to HE here and click on make. Here's an example make file here. It makes things a lot easier. So from here, it automatically can do the LD to work with generate your assembly programs. And then down here, it compiles your assembly programs. And here, if you do C programs, this is all it runs to compile a C program. It runs C65, CS65, and then LD against HE bin, and then outputs it with HE lib. HE lib's also included here as well. So if you go here, you'll see HE bin, the file I just showed you. That works. HEbin.o, the file that you need. This contains the header and everything. This contains a C library. If you're going to do C programming, you'll need to have this for sure. This is also for C as well. It's a header file for doing various C components, very specific components related to Hacker's Edge and C. And then, of course, you have the IO API code, which is also, I also showed you that. And then, of course, the kernel inc, which I'll go through in a few seconds and explain that a bit more. And, of course, the README file. I'll actually have to, on the website's documentation, which is very useful to have, if you go to Hacker's Edge/Help Center, you'll see quite a lot of stuff here. So if you go to programming, you'll see some example programs here, along with a bunch of other extremely helpful stuff. There's also the kernel APIs. Ooh, I got to update this document. Last updated 2016. Okay, this is outdated. I need to update these. So please don't look at these yet. I have to update them. Anyways. Okay, so here's the basic kernel API here. So you have the print. I showed you that example already in code. You just set A and X. Same with input, set A and X to your address. And this one, compare string, requires param1 and param2 and the results in result. Memclear uses param1 as the address you want to clear, and then the size is in Y. Same with memcopy, uses param1 as your source, param2 as your destination, and then Y as the amount of bytes you want to copy. And then fload and fsave are not fully tested yet. Fload is. Fsave has reported to have problems, so don't use fsave yet unless you want to beta test it. And load config, this is just internal stuff for loading config files. Is internal to the kernel. Don't bother using them. right now. Print IP prints the an IP address that's located in the network segment using with the Y register as an index. Listen is a network API to help listen on a server. Stop server is for stopping the server. You just start with listen, and then connect, of course, is to connect. And then you have the arguments. This is for kernel arguments for if you want to read input. Like I'll show you the echo command as an example here. Echo is a good example on how args works. This is supposed to be args and args plus 1, but right now I didn't do that exactly. And then we do a JSR to that. JSR to the print function, and then we do our beautiful LDA to store a return after our echo statement, right? So, and then we have the HE. This is the C code here, which is highly more recommended in the assembly if you want to make it easier on yourself. This gets the parameter from the command line. This loads a file into a specific memory address. This grabs the network segment. If it's 0, that means the network is currently down. Listen on a port. Close the listening port. Reply back. Send data on the open network socket. Connect to a remote host. Network receive. ASCII to network address, and network to ASCII. And these functions will be growing much more in the future, of course. So these are just the current kernel functions, but as time goes on, there'll be more. And I'll be making a tutorial in the future that actually goes through the C API, but that won't be for a while because I'm going to be updating the kernel soon to kernel version 1.0, which will include a vastly different API, and C will take advantage of that, which will allow for much smaller C programs. Because right now C programs are fairly large. As an example here, I'll show you. So let's go into ASM macroOS. Okay, so here is like ls bin. This is an assembly program. 76 bytes, very tiny. Now here is a program I coded through C. 562 bytes, very large. So as you can see, C programs tend to be incredibly large compared to the assembly counterparts for very good reasons, but I'm planning on implementing a lot of those APIs into the kernel, so when you make C programs in the future, the code will actually be fairly small. But anyways, I think that's the end of this live stream, or as far as I should be going right now, because it is getting late, and I only wanted these streams to be short, just enough to be able to watch for people to get ideas and